In this video, I'm going to build my data prediction using Gemini AI. For that, I'll start with a sample dataset from Kaggle. So we have a description. Description consists of data about the Titanic disaster, and the prediction would be pretty much like asking us about whether the the passenger is survived or not. So looking at the data, we have whether the passenger survived or not, and the ticket class, uh, and we also have gender and the age in years, and we also some other sibling data and ticket number and cabin number. So we can see the variable as if the P class is 1, 2, or 3, it would be like first, like 1, 2, or 3. Okay. It depends on the ticket economy and the, the data set has relative information, and finally this is how we submit our data. We put our passenger ID and whether they are survived or not as a 0 or 1. So let's start with downloading our data set. For editor, I'm going to use Google Collaborator. I chose Google Collaborator because Google Collaborator has a built-in Gemini support, which auto-completes and builds model for our data. So this is our folder. I have train and test data on our Titan notebook. Opening up the notebook, it would be Collaborator. Now let's check our notebook on how it is. Right? We can see start coding and generate with AI option. Generated AI is pretty much like Gemini AI. You can see that our editor is supported with Gemini AI in this corner. Clicking on this, you get a chat with the chat option with Gemini AI, where we can type our prompts and get our code. I am definitely interested to use this part in our coding. So let's start with our pandas dataset. So let me type some intro context for this prediction. Before that, here is yet another notable item. We have different environment to run our script. This is something that I don't want to miss when I was explaining the collaborator. So with the introduction, I'm just installing the initial package, which is pandas, and mount our CSV data. I can see the is complete already, but we are not going to use all these packages. We're just going to use pandas for now. And Google Colab. Right. Oh, this autocomplete is really helpful. So this is the path that we are going to specify to our directory to bring our test and train data and fetching data from source. Source is nothing but our drive. Now we'll add more explanation. Convert the CSV to PD data frame. Okay. Now let's use this mounted path to define the path for our data. What I'm explaining is not understandable. Let me try to get this out of Gemini. Mount the CSV data to it gave us some description. I thought it would generate in the file. I'll do one thing. I'll simply copy the prompt and paste it in the generate. This is good, but this is not exactly the correct path that the mount we can see like content drive, and we will replace it with our own path drive Kaggle Titanic. Right, drive Titanic on the train CSV. We'll do the same for test CSV as well. I'll put just df1, df2, and test. Now if I click on the run, first we will do one thing. We'll take head of the data. It will give first 5 data. I think we are failing. Yeah, I made a mistake there. Okay, now we got our data set. Let's now try to understand our data. So we have passenger ID, survey, C class, name, uh, and other information like ticket and cabin. Next step is data cleanup. Some of this information that we have here, like name, fare, and cabin, are non-numeric columns, which doesn't really help with the data prediction. We only needed numerical columns for the prediction. So first thing is removing non-numeric, pretty much like alphabetic column. Second one is like normalizing our data, which is like turning the categories into numerals. I'll explain more about that. So here in this table, we are not going to use this name, ticket, and the cabin information. I actually forgot to add one more cleanup process, which is like fill NA. What it does is like if there is an empty column, which is like a null or a zero column, what we will do is like we will fill the column with the mean of other values in the column. This is I will show that what it is. Now removing a non-numeric column, is it actually generated by Gemini? It's correct actually. All the columns it was saying is actually correct. But I'm actually looking into something else. This P class value count. Let's run this. We can see this category like 3, 1, and 2. We have this number of count records. When it comes to normalizing, what I will be doing is like I will split it into three columns. And if we have P class 1 as true, others will be false, which explains that our row is P class 1 and it's same for the 2 and 3. This is one way of normalizing, but we are not going to go deep into that. Now let me understand this Gemini code. It is actually correct. Yeah, it's actually correct. We need name, ticket, and cabin to be removed from test and train data set. Now if I try to see the head of DF1, let's, yeah, let me quickly fix that. This in place true is not actually required. I'll assign it to a variable. We need to assign it to a variable. So yeah, on the in place true, I'll remove this one for the time being. Now let's try to run that. Yeah, we can see in our data frame the three columns has been removed. Uh, so we will proceed with other two steps as well. So in our data, we have male and female in our gender, which pretty much we can categorize it as 0 and 1. And we have embarked the column, which is like text. We will do categorize those as well. For now, we will see this parse. This field should not be empty because we are using this for the prediction. We will fill the empty columns with the mean. Here is another column which should not be empty. It's C plus B. So we will do the same thing for this column as well. So let's have a look at our data. I have some doubts whether these are not the enough columns. Let's try to understand our data. Yeah, which is like we class 6 and parsing 6 is what we checked just now. Yeah, I think we are good. We'll try to clean up the data. First thing is like, wait, did I just now Gemini try to autocomplete this part of the code? Actually, it's correct. It shows the correct column and fill and A is where we fill the columns with the mean value. This is actually correct. Let's classify these steps. First one is like removing the non-numeric columns and fill value. We'll do that with the test data as well. So now we need to do some normalizing the column. Second step. Uh, yeah, let me quickly fetch the data. We did get some warning. Let's ignore that. Not just depending on me, we can also do median. That's something I need to explain. So the next step is normalizing. So we also have this column called embed. We have to fill some dummy category for that column as well. For that, hey, this is okay. This is good. So we can fill the column with U, and later we can replace it in the prediction. So let's convert the categories into labels. For that, I'm going to use the scikit-learn package, which is pre-processing label encoder. Y- Yeah, yeah, this is actually correct. Please have an import. Now I'll try to transform the data and check the head. Let's quickly do a data. So, and, yeah, we got the warning. Let's scroll down to check our data. As usual, df1 dot head. Let we actually got a numerical label representation of all the data, even for gender, if it's male and female, it's one or zero classes, and even the embarked thing, which is categorized as B, C, D, A, is actually turned into 201. This is what the label encoder does for us. This is really helpful for prediction, basic data. So next thing, let's start with prediction. For prediction, I'm actually planning to use two regression algorithms. One is linear and logistic. I choose linear regression for this for comparison purposes only, but the real regression would be logistic regression. It got completed. We got the strength split and accuracy score to calculate the final result. This is actually really correct. Now let's start with linear regression. In linear regression, first let's prepare our X and Y data, and let's start with getting our X train and Y train data. Now let's try to get our accuracy score with the test data. I really like the autocomplete part. Now the accuracy score would be like, hey, okay, this is not how we calculate accuracy. Let me quickly rephrase this one. It's, let me remove this part and try to write score. Actually, this is not the right way. We will do linear regression dot score and X test and Y test data, and we got our accuracy, which is 43. This is not the correct accuracy, not the correct algorithm to use this. So let's go with logistic regression. Here, let me try to generate our prediction. I'll put this X10 and Y10 in a common place. Now for logistic regression for trained data. This is good. The accuracy is also, let's calculate the accuracy. It's 81. This is actually pretty much the correct. Now, we typically always complete our ML predictions with the visualization, even though here the visualization is pretty much for zeros and ones, which is not an ideal one, but still it was, yeah, like I said, it's zeros and ones, so it's not good. But I was really happy everything was taken care by Gemini. And finally, let's get the output. Get the predicted data as, sorry, I'll paste here. And if we run this, actually got the downloaded version of the submitted data. This is exactly the format which was expected in Kaggle. I'll see if the submitted data works in Kaggle. Now opening Kaggle and submitting this file. Our result was actually accepted. It's actually successful as well. And generated by Gemini AI, correct? It was a successful result with the public score of good value. So here this is the synopsis of my notebook, introduction to conclusion. I will add this to the description of this video. Do check this out as well. Thank you.